Alright guys, welcome back to part 2 of exam style differential equations. Obviously these are exam style, but we're gonna get into the more harder stuff later down the line. So it's just a prep, but these are exam style differential equation type questions. Just before I get going guys, make sure to like, subscribe and share these videos. If you know anyone that's struggling and could use some help, definitely share them. It really helps the channel guys and keeps the momentum going, you know. So without further ado, let's get into it. So question 4. Okay, the variables x and theta satisfy the differential equation. Okay, sine half theta dx by theta is equal to x plus 2 cos half theta. Okay, right. Solve the differential equation and obtain an expression for x in terms of cos theta. Right. So how do we go about doing this? What I'm going to do is I'm going to say, fine. First thing we need to do is put each of these onto one side. Okay. So how do I do that? Well, what I can say, guys, is 1 over x plus 2, okay, dx is equal to cos of half theta over sine of a half theta d theta. Okay, cool. And so what do we do next? Well, we're going to integrate it, right? Brilliant. Right. Now from here, it's pretty simple. We just have to recognize the following facts, okay? So over here, notice that this is in the form of f dash of x over f of x, okay? Because cos is the derivative of sine, okay? But it has to be, we're going to have to use a chain rule when we integrate it. So what I'm going to say now is, okay, 1 over x plus 2 is pretty simple. It's just ln of x plus 2, okay? And so this here is going to equal 2 of ln sine half theta, okay? And of course we're going to have c there. Now why do we put the 2? Because remember chain rule. We're going to divide by half. Right. Now it's pretty simple. All we have to do is use our initial condition. So when x equals 1, theta equals pi over 3. Cool. So using this information, I can say, fine, well, ln 3 then is going to equal 2 ln of pi over 6. Of sine pi over 6 plus c. Okay. Okay. Well, therefore, ln 3 is going to equal 2 times ln half plus c. Which then means, especially given this, that I can say, fine, well, ln 3 is equal to 2 times ln 1 minus ln 2 plus c. Okay, if you remember the ln rules of ln over b is equal to ln a minus ln b, right? So cool. So ln 1, that's not going to give us anything. So we can say, okay, fine, ln 3 is equal to negative 2 ln 2 plus c. All right. Then what does c become? Well, c becomes ln 3 plus 2 ln 2. Okay. which then becomes, okay, c is going to equal ln 3 plus ln 4. Why? Because this 2 is going to come over and act as a power, right? So this means, therefore, that c is equal to ln 12. Right. Therefore, we can say the following. What we can say is ln x plus 2 is equal to 2 ln sine of a half plus ln 12. Okay. Now from here, guys, we can say the following. We can say that, okay, knowing this, we have to ask ourselves, what is sine of a half going to give us? Right? Well, let's think about that. So remember that this is a ln, okay? So it's a ln sine half theta. So technically this 2 can act as a power. Okay, so if the 2's been dragged down, it means the 2 could be a power as well. So therefore we're going to get ln x plus 2 is equal to 2 ln, okay, sine squared of a half theta. 2 shouldn't be there. Okay, so ln of sine squared of half theta plus ln 12. Right. And what does it mean now? Well, if these are together, we can basically multiply it together. So we can say, fine, well, ln of x plus 2 is equal to ln of 12, okay, times sine squared half theta. All right. Now we can get into the nitty-gritty, so to speak. Because what I can say from here is, okay, cool. If we raise these both to the power of e, what we're going to get is x plus 2, okay, is equal to 12 sine squared half theta. But now the question becomes, guys, what does sine squared of a half theta equal? Well, if we go back to our formula sheet, we'll know that firstly sine squared theta is equal to 1 minus cos 2 theta over 2. Therefore, what we can say from that logic is that sine squared of a half theta must equal 1 minus cos theta over 2. Okay, so what can we say? We can say, fine, well, x plus 2 then must equal 12, right, times 1 minus cos theta over 2. Perfect. Okay, because we plugged this in. So from here, we can simply say, all right, x plus 2, okay, is going to equal, well, actually, what we can say is, yeah, it's 2, 12, 2 theta over 2, okay, x plus 2, and then it's going to equal 6, 1 minus cos 2 theta. Okay, so therefore x plus 2 is equal to 6 minus 6 cos 2 theta. Therefore, x is equal to 4 minus 6 cos. There should be theta here. Okay. So therefore x is going to equal 4 minus 6 cos theta. Right, and that, guys, is going to be the final answer to the question. Right, guys, now for question 5, we were asked the following question. Variables x and y satisfy the differential equation dy by dx is equal to y minus 1 over x plus 1 times x plus 3. Right, and it's given that y equals 2 when x equals 0. Right, solve the differential equation. Fine. Cool. So, 1 over y minus 1 dy is equal to 1 over x plus 1, x plus 3 dx. Okay, but now we have to get this in partial fraction form, guys. So what I can say is 1 over 1 minus y, 1 minus 1 dy is equal to, in fact, actually, let's take this one step at a time. Okay. Let's focus on this. Okay. So this here is going to equal a of x plus 1 plus b x plus 3. Okay, so therefore 1 is equal to c plus b I can therefore say that from here, so if I let x equal minus 3, so therefore 1 is equal to b minus 3 plus 1. Right, and so 1 is going to equal minus 2b, b is equal to minus a half. Brilliant. Meanwhile, if we let x equal minus 1, then 1 is equal to a, okay, 1 is equal to a is then equal to a half. Okay, cool. So from here then, what we can say, guys, is therefore this is going to equal 2x1 plus cool. Perfect. So we got that sorted. Now the next part is to put it together. Okay, so then we therefore have what? 1 over y minus 1 dy. Okay. It's going to equal 1 2x plus 1 minus 3 dx. Okay, but now we're going to integrate both sides. Right. Cool. Now, very simple. All we have to say is, okay, ln of y minus 1, right, it's going to equal a half. Okay, I'm going to take out the half here. And there's going to be a half ln x plus 1 minus half ln x plus 3. Okay, plus c. Right, now we have to recognize that, okay, when x equals 0, y equals 2. So therefore we can say the following. Ln of 1 is equal to a half ln 1 minus a half ln 3 plus c. Right, so therefore we can say that c is equal to a half ln 3. Okay, so therefore what do we get? Well, what we get is the following. We can say that ln y minus 1 is equal to a half ln x plus 1 minus a half ln x plus 3 plus a half ln 3. Alright, cool. So therefore, we can say the following. We can say again that ln y minus 1 then is going to equal a half of basically 3, okay, half of ln of 3 times x plus 1 over x plus 3, okay, so according to log rules. But this plus this, so therefore they multiply and it's going to be divided by that. Alright, so we can then say the following. Ln y minus 1 is going to equal ln 3x plus 1 x plus 3 power of a half. Okay, so therefore we can say that ln y minus 1 is equal to the ln of 3x plus 3 over x plus 3 power of a half. Right, so therefore y minus 1 then, guys, is going to equal what? Well, y minus 1, we can say it's going to equal 3x plus 3 over x plus 3 to the power of a half. Right, which tells me that y minus 1 is the same thing as saying 3x plus 3 over x plus 3, which means that y is going to equal 1 plus 3x plus 3 x plus 3. Right, and that, guys, is going to be the final answer to that question. Right, guys, now for question 6, I'm going to say the following. Okay, variables x and t satisfy a differential equation. Okay, x equals 0 when t equals 0. Fine. Solve the differential equation and obtain an expression for x in terms of t. Alright, so how do we go about doing this, guys? First thing we're going to do is we're going to say, fine, well, let's write it out. Cos squared 2x. Cool. We're then going to separate. I'm going to put them onto two sides. Right, so what we get then is 1 over cos squared 2x dx is going to equal 1 over e to the power 3t dt. And what is 1 over cos? Well, 1 over cos is simply going to be sec, right? So therefore 1 over cos squared 2x is equal to sec squared 2x. So what we get, sec squared 2x dx is equal to e to the negative 3t dt. Right, now let's integrate both sides. So the integral of sec squared 2x dx is equal to dt. Okay. Cool. So from here, what's the integral of sec squared 2x? Well, we know what the integral is of sec squared x. The integral of sec squared is tan x. So therefore, in this case, it's going to equal tan 2x over 2, because of course you have to divide by the inner function due to chain rule. Reverse chain rule, actually, this is. And then over here, minus 3t, I'm going to divide by minus 3. But we need to add the plus c. Okay? Cool. So, where do we go from here? Well, we know that x equals 0 when t equals 0. Okay. So when x equals 0, okay, cool. So we can say fine. Tan 0 is equal to e to the 0 over minus 3 plus c. So 0, negative third plus c, which tells me that c is equal to a third. Brilliant. So what does the equation become? So therefore what we're going to say is the following. So half tan 2x is equal to minus a third for e to negative 3t. Okay. Plus c, what's c? It's a third. Brilliant. Right. We can therefore say from here, guys, we can say that, okay, cool, tan 2x must therefore equal the following. Must therefore equal negative 2 over 3 e to negative 3t plus 2 over 3. Brilliant. Alright. We can therefore take this common factor out now. Okay, and say fine, 2 over 3, 1 minus e to negative 3t. Okay, so therefore 2x is equal to what? 2x is going to equal tan negative 1 of 2 times 2 over 3. Alright, cool. So therefore what? Is equal to a half minus tan minus 1, 2 over 3. Perfect. Alright. And that, guys, is going to be the final answer for the first part. Okay, so what does it say? X in terms of t. Simple enough. But now, state what happens to the value of x when t tends towards infinity. Well, here, I'm going to say the following. So what is our result, firstly? Okay, our result was x is equal to a half tan minus 1, 2 over 3, 1 minus e to minus 3t. Okay. Now, using this result, I can say the following. Okay. I can say that x is equal to half tan minus 1, 2 over 3, 1 minus 1 over e to the 3t. So as t goes towards infinity, guys, okay, I know that 1 over e to the 3t tends towards 0. Why? Because this gets bigger and bigger, so therefore the whole thing gets smaller and smaller. So therefore, I can say that x is going to tend towards a half of arctan. Okay. 2 over 3. And what's this here? Well, 1 minus 0 is just 1. So it's going to tend towards half of arctan 2 over 3. Okay? So therefore, as t tends towards infinity, x tends towards a half arctan 2 over 3. And that, guys, is the final answer to the question as a whole.